Imagine this. You're floating completely alone in space. The Earth is far behind you. The sun shines in the distance. And suddenly, a massive star explodes nearby. An explosion millions of times more powerful than every nuclear weapon on Earth combined. You would expect a deafening roar, a sound so powerful it would shake your entire body. But something shocking would happen. You would hear absolutely nothing. No boom, no explosion, no sound at all. Just complete silence. How is that possible? How can the most violent events in the universe happen without making a sound? Why is space completely silent? And what would happen if you removed your helmet and tried to listen for yourself? The answer reveals one of the strangest truths about our universe. A truth that most people never realize. To understand why space is silent, we first need to understand what sound actually is. Many people think sound is simply something we hear. But sound is actually vibration. Every sound you've ever heard began with something vibrating. When you clap your hands, the air between them vibrates. When someone speaks, their vocal cords vibrate. When thunder strikes, the surrounding air vibrates violently. These vibrations travel through the air as waves. Eventually, those waves reach your ears. Your brain interprets those waves as sound. Without vibrations, there is no sound. And without a material to carry those vibrations, sound cannot travel. This simple fact explains one of the biggest mysteries of space. Right now, you're surrounded by air. Trillions upon trillions of molecules are constantly moving around you. When a sound occurs, these molecules pass the vibration from one molecule to another. It's like a giant chain reaction. Imagine a line of dominoes. Push the first one. The movement spreads through the entire line. Sound works in a similar way. Air molecules transfer energy to neighboring molecules. The vibration travels through the atmosphere and eventually reaches your ears. But what happens if there are no dominoes? What happens if there are almost no molecules at all? The chain breaks. The sound disappears. And that's exactly what happens in space. Space is often called a vacuum. A vacuum means there is very little matter. No air, almost no particles, almost nothing. Because there are so few molecules, sound waves have nothing to travel through. A supernova can explode with unimaginable power. The universe becomes eerily silent. Not because nothing is happening, but because there's no medium to carry the sound. But here's where things become interesting. Space isn't completely empty. This surprises many people. If space isn't empty, then shouldn't sound be able to travel? Technically.
Subject 04 is in position. Initiate the transmission now. Copy that, Houston is receiving. The view from here is incredible. Subject 0 Cloer is in position. Get back to the rover now! What? I don't see anything. This is not a drill. We are out of time. Look!
In the silence of space, radio waves carry the signal, connecting astronauts across the void. From suit to suit, radio saves communication, ensuring every voice is heard.
Yes. But only under very special conditions.
System diagnostics.
Although space contains gas and particles, they are incredibly spread out. Far more spread out than Earth's atmosphere. The density is so low that sound waves become extremely weak. Instead of traveling quickly and clearly, they lose energy over enormous distances. In practical terms, space remains silent, at least to human ears. Now imagine you're standing on the moon. You and your friend are wearing spacesuits. You're only a few feet apart. You shout as loudly as possible. What happens? Nothing. Your friend hears absolutely nothing. Not because they're too far away. Not because your voice is weak.
This frequency is anomalous.
It is coming from the galactic center.
Let us isolate the source.
But because there is no atmosphere between you, the sound cannot travel. To communicate, your suits must use radio signals. Your voice is converted into radio waves. The radio waves travel through space. Your friend's suit converts them back into sound. Without technology, even someone standing right next to you would hear nothing. But if space is silent, why do movies make it sound so loud?
Check the telemetry on Sector 4. The readings are spiking. I see it. Rerouting power to stabilize the orbit.
Think about your favorite space film. Huge explosions, roaring engines, massive battles. Everything sounds incredible. The truth is that almost all of those sounds are scientifically impossible. In reality, space battles would be strangely quiet. No giant explosions, no roaring spacecraft, no thunderous impacts, only silence. Hollywood adds sound because silence feels unnatural to human audiences. Without sound effects, many scenes would seem boring. But scientifically speaking, space is far quieter than most movies portray. Yet the story doesn't end there, because scientists have actually found ways to hear space. At first that sounds impossible. How can you hear something that has no sound? The answer is fascinating. Scientists can detect electromagnetic waves, radio waves, plasma vibrations, and pressure waves throughout the universe. They then convert those signals into frequencies humans can hear. In other words, they translate space into sound. You've probably heard recordings online called "the sound of a black hole" or "the sound of Saturn." These aren't recordings made by microphones.
Listen to the cosmos, for I have stories to tell.
They're scientific data converted into audio. The sounds are real representations of cosmic activity, but they aren't sounds that human ears could naturally hear in space. One of the most famous examples came from a galaxy cluster hundreds of millions of light years away. Scientists detected enormous pressure waves moving through hot gas. When converted into sound frequencies, the result became known as the sound of a black hole. The pitch was incredibly low, so low that humans couldn't hear it directly. In fact, it was dozens of octaves below human hearing, yet it revealed something astonishing. Even the universe has rhythms. Even giant black holes can create waves. This leads to another question. If space is silent, what would happen if you removed your helmet? Movies often show dramatic explosions or instant freezing. Reality is different. The first thing you'd notice isn't sound. It's the absence of sound. Complete silence. More complete than anything you've ever experienced. No wind, no birds, no traffic, no voices, nothing. Just silence. Then the vacuum itself would begin affecting your body. Without protection, survival would be extremely difficult. But contrary to popular belief, you wouldn't instantly explode. You wouldn't instantly freeze either. The reality is far stranger and far more terrifying. Scientists often describe space as one of the most hostile environments imaginable. Extreme temperatures, deadly radiation, micrometeoroids traveling faster than bullets, and complete isolation Yet among all these dangers, the silence remains one of the most unsettling. Human beings evolved in a world filled with sound. For millions of years, our brains have relied on hearing. Sound helps us detect danger, communicate, navigate, understand our environment. Remove sound completely, and reality begins to feel unnatural. Astronauts have actually spoken about this feeling. When looking out into space, many describe a strange sense of isolation. The universe appears alive. Stars shine, planets move, galaxies rotate. Yet everything happens in silence. It's like watching the greatest movie ever created with the volume turned off. A cosmic performance without a soundtrack. And perhaps that's what makes space so fascinating. The universe is incredibly active. Stars explode every second. Galaxies collide. Black holes consume matter. Neutron stars crash together. Entire solar systems are born and destroyed. Yet despite all this chaos, space remains silent. A silent stage for the most powerful events in existence. So why is space completely silent? Because sound requires particles. And space contains too few particles for sound waves to travel effectively. The explosions are real. The violence is real. The energy is real. But the sound never reaches us. The universe doesn't need noise to be powerful. Its greatest events happen in silence. And perhaps that's the most mysterious thing of all. Out there, beyond Earth, beyond the planets, beyond the stars, the universe is performing its greatest symphony. A symphony that no human ear will ever truly hear.
Is alive.